like to introduce our next presenter, Jason Spotwood. Thank you for bearing with us there for a minute. He's going to be speaking today on Redfish implementations. Jason is a senior firmware development manager for hybrid IT at Hewlett-Packard Enterprise. Thank you.
Thanks. Everybody can hear me? Well, I'm here to talk about Redfish. So first I'd like to kind of poll the audience. Who here has heard of Redfish? Nice, okay. Who has actually used Redfish on a server? Who has actually logged in and used Redfish on a functioning server? About 3 people. And then lastly, who has actually implemented UEFI for Redfish on a server or on equipment? 1, 2, 3. All right, awesome. My target audience is this big. All right. Well, so today I just want to dive into a little bit of, got one slide, a little recap of Redfish, overview of Redfish. I want to go into the different implementations that we've seen in UEFI for Redfish throughout the industry. Talk about one of the problems that has arisen from that and solutions and future proof of concept spec updates. So what is Redfish? Redfish is a RESTful API, secured multi-node replacement for IPMI. It provides out-of-band access to the infrastructure through the BMC typically, which you'll see on a server that implements Redfish. The BMC is the service provider. Client machines can log into that service and get a wealth of information from the system through inventory collection, services provided by Redfish like log services or firmware update services. It also provides configuration capabilities for the platform. So all of that data is collection of JSON files that are all schema backed by the DMTF, all spec'd out and all great. And the example that I have up there is the computer system schema, which has your like product name, serial number, all the kind of information that you're wanting to get from the computer system. So where does UEFI play in all this? UEFI and BIOS is an external provider into the Redfish service, meaning that during boot, the BIOS registers with the Redfish service and provides all of its data files for hosting by the Redfish service. The BIOS, when it's booting up, provides the BIOS resource, which is the BIOS resource file itself is backed by DMTF schema, follows the BIOS schema. And with that, another file that's provided is the BIOS attribute registry. So inside the BIOS resource, you'll see one section there called the attributes array. And the attributes array is really a collection of all of these system configuration options for that's managed by UEFI that you would typically see in like a pre-boot configuration utility. That attributes array and the contents of that attributes array is not something that's spec'd out in the DMTF schema, but it is described in the BIOS attribute registry. The attribute registry is also backed by schema, but the contents and how it's created and the attributes therein are not spec'd out and backed by any sort of Redfish schema. So how this gets implemented and created by the BIOS or the OEM vendor is all implementation specific. And this long list of attributes and the attribute registry that describes all the attributes is very much vendor specific and implementation specific. So from that, therein lies the problem. So today, BIOS attributes are not standardized, and when you go and look at servers, implementations across the industry, there's no two that are similar because there's no implementation guidance on how to create these attributes for the system. The 2 examples I have here show a very similar mapping, but just slightly off in the attribute naming. A third example, and I used fake server names just so I'm not pointing out any fingers. But the attributes are supposed to be human readable, and we've seen cases through competitive analysis where things are not human readable. Cryptic attribute names, And in this third case, the values are completely different. So the problem that comes into is there's zero interoperability. Any sort of scripts that a system admin would want to run throughout all the servers in a heterogeneous data center do not apply to these different implementations. So this gives a good opportunity for UEFI to kind of define an implementation guidelines and how this could be created and how the BIOS resource should be created. One area that Redfish has helped a little bit is in these two examples for secure boot and boot order configuration. The DMTF has specified schemas that define these standard, very common functionality pieces like boot order and secure boot. Let's see, so the secure boot, the example I give up here shows the secure boot schema. These items are maintained by the BMC, by the Redfish service. So these are not managed by UEFI under the BIOS resource. These are managed by the Redfish service. And it's up to UEFI and the BMC to kind of communicate any changes to this data or any updates to these resources, and that's all implementation specific. But this is a preferred method from the DMTF's point of view, is as things are identified that are extremely common functionality blocks, that they get pulled out and maintained by the Redfish service. I just throw this up as kind of a disclaimer, I guess, because the DMTF does prefer this kind of methodology. One recent, I guess, new development is there's been some work with certificate management for HTTPS boot and secure boot certificate management, and that's being done under the DMTF Redfish work group, and those discussions are ongoing right now. Yeah, so out of all this schema, you can see I pointed out one particular item that's a settable item that is an option in most BIOS implementations in their pre-boot environment. This is the secure boot enable disable option. Another disclaimer, so for I/O devices, I/O device configuration, you do see most I/O device vendors have a pre-boot, like HI kind of menus for configuration. The DMTF has recently published a PLDM Redfish device enablement spec, and that is the preferred method for configuring I/O devices. So it's preferred because it's out-of-band access. It provides services to the I/O devices through PLDM, firmware update, inventory information, and configuration through Redfish device enablement. And the only reason I say this is because it's not something that should be under the umbrella of UEFI's responsibility by in the BIOS resource. So what does that leave us? What does that leave us to configure under the BIOS resource in Redfish? So we've got any sort of vendor-specific settings, silicon vendor-specific settings, OEM vendor settings, anything that wouldn't be common that would be pulled out into Redfish proper would be then under the umbrella of UEFI's responsibility in the BIOS resource. So given these target areas that we've identified here, we need a process for vendors to define and publish attributes, and where the community can come together and kind of agree upon attributes and create a common registry of attributes. Luckily, so there's already a place out on UEFI forum today, and somebody pointed this out yesterday. The UEFI configuration namespace registry already exists, and it's a collection of common ex-UEFI keywords that have been published out on UEFI forum. This is a great start, a great foundation. This provides a list of common keywords. And what's interesting about keywords is they look a lot like Redfish attribute names. And so you can start to see the vision is that we could take a list of keywords and convert those to BIOS attributes and start to build up some sort of common implementation. So this is for common common keywords, common attributes, settings. But where do the vendor specific things go? And I believe on that same website you can have like a process where you provide your vendor specific settings through there. I call out some blocks here where a vendor that wants to define stuff would just tag an X UEFI and vendor X name on that and publish those through the same process. And so you have the X UEFI NS namespace there, but you can also have vendors publishing the vendor unique settings through that same process. One thing I mentioned here, so right now, that particular registry is not versioned, so that's one enhancement to that today. And there's a little tweaking of the naming scheme that's been used for the keywords today, that they're not exactly conformant to Redfish, so right now there's no real one-to-one mapping. You can't take a keyword that's out there and map it straight to an attribute registry because it's against some of the rules. So maybe some tweaks there as well, but very minor. So given the blocks that we were talking about here, that vendors have created their registries and we have common registries, those blocks they can't all exist in a flat attribute array within the BIOS resource in Redfish. The reason being is because attributes can't share the same names. You can't have duplicate attribute names. And you can't exactly tell vendor A and vendor B that they can't have the same type of setting name. It may do different things, and they may call it the same coincidentally, but you can't mandate that. So in order for us to kind of have this all under one collection, we have to partition it up. And each vendor or each component gets its own kind of section within the BIOS resource under Redfish. And to do that, we had the idea of creating this platform attributes array where you can have multiple registries within the BIOS resource, each registry for a different component within the computing system. So the benefit to this, as you can see, OEMs that use the same components would pull in the same keyword registries from the reference code that's been provided by those components, and that would get translated into a separate section of the BIOS resource, all versioned and named the same, and have the exact same attribute array within their partition of the resource. So it improves interoperability across all the different servers. So how would we go about doing this programmatically? It's one thing to talk about it and how you'd partition it up, but programmatically, how does UEFI do this translation? In UEFI 2.8, they added the rest style class GUID to the VFR syntax. So that's one key little trigger that you can key off of so that when we're booting up, you can use that to kind of identify form sets that follow this rule set. Furthermore, we would mandate that all the questions would have to have XUEFI keywords because that makes it human readable. You know, XUEFI keywords are human readable. So that's another stipulation of attributes within a BIOS attribute registry. Some new items that would need to be added. So we talked about the versioning, and we talked about the name for the component that you're targeting. Those are kind of some new syntax that would need to be added just so that you can guarantee interoperability between the different components. So then once it's all said and done, you got a working implementation here. What you would see is during either build time or boot time, all the different form sets that follow these rules would get sucked in and converted into BIOS attributes and into the BIOS attribute registry. And then that would be published and registered as through the Redfish registration during boot time. So that's kind of the vision, that's kind of the goal. Right now there's a proof of concept work that's been done mostly by Intel. It's not exactly this implementation. This implementation is defined on top of that. The current proof of concept code is very comprehensive and going into a lot more than just this. But the reason I'm here speaking today is because there's a big problem with interoperability between the different vendors with the attributes and how you do BIOS configuration. And so I'm trying to address that. And that will start appearing in this proof of concept code as well. And then there will be several spec updates that we're looking to add. Definitely want to get into talking about Redfish more in the UEFI spec, a chapter that kind of goes into the implementation and giving more guidance there. Some updates to the HII, and to talk about if we go into this translation of HII to Redfish, we'd have to mention that in the spec as well. VFR syntax changes, and lastly, the DMTF doesn't allow multiple registries, so that will have to be updated as well. So what does that mean for everybody here? Well, the keyword registry seems to be largely unused. I don't know that anyone defines keywords for their HII. So that would be a big call to action, is that as people are working on HII for their components and doing things, that they start defining these keywords and publishing them and registering them with the namespace registry that's out on the UEFI forum. Also ask that everyone start to contribute with the proof of concept work and any discussions that we have in the future for spec updates. One bullet item I didn't add up here, but in the DMTF, there's a lot of discussion about UEFI, but there's not really a whole lot of UEFI representation in the DMTF. And so you hear discussions going on in the DMTF, and there's no feedback for UEFI. It's just kind of falls on deaf ears. And so it'd be great to have more participation at the DMTF from the UEFI community. That's all I've got. Any questions?
So this is actually a question, I think I know the answer you'll give, Jason, so I'll actually ask everybody else. So I noticed, well, one of the items that you had was the extensions to the VFR. And right now, I mean, for a long time we've talked about VFR going into the UEFI spec, but we've kind of held back because VFR is kind of like the analog to the C to the opcode. The opcode is the architectural thing, the C is kind of an implementation on top of it. But there's been actually a lot of talk about why don't we roll VFR into the UEFI spec? And I'm just kind of poll the audience in general. Does anyone have any concerns or questions about actually putting VFR into the UEFI spec as one of those, you know, next step type of things? Do you see that as useful? Because I think inevitably right now VFR as this spec kind of is a standalone, it's not part of UEFI at this point in time formally, though everyone seems to use it. So I'll leave that as just an open question to anyone who has it. Say again?
I'd love to see it be part of the spec.
Yeah, I mean, like the class GUID that you see here, that the REST style that was added. Yeah, there'll be some things that you look around and it's like the VFR syntax is kind of mentioned in a certain way. Some of the information that you'd find in the form set is there, and then you have to go to a whole nother spec to look into more about the VFR syntax. So it does make sense to kind of combine those in.
Right, because right now, all the VFR inevitably translates into an IFR opcode, which IFR is part of the spec. So I mean, since IFR is essentially the compiled version of VFR, but everyone, any developer who's actually writing any of these config pages, they're writing VFR. They don't, you know, they assume that the compiler is going to do what it needs to do. We don't look at the opcodes for our C code anymore, not often anyway. Yeah. So yeah, we kind of work in C or work in VFR for this case. So.
I'll be available after at the office hours in case other questions come up. But anything else? No? Question over here.
Hello. There seems to be a PLDM for BIOS control and config specification as well, and a PLDM for SMBIOS as well. Could those spec, can we leverage those spec and kind of convert that into the JSON format and add it to the?
I'm not familiar with the PLDM to that level. I'll have to go look into that. I don't know. I guess there could be a way that from like right now it's IO devices doing PLDM. I don't know if there's any avenue for silicon vendors to start opting in and using that, and that's a way to do kind of configuration through that with other components within the system, perhaps, yeah.
Are there plans to have a Redfish UEFI shell command line app that could be used by multiple vendors, or are we going to be deferring to vendors to making their own tools for that in that regard?
I don't know that there's any plans for the community to draft up. I know different server OEMs have their own, I know HPE has our own app that runs under our shell that can do Redfish client stuff. But
There's some discussion about it, nothing formal yet.
Okay.
At least from Intel's side.
yeah, I mean, one thing that wasn't mentioned, so there's and I guess you guys are going to talk about the Redfish host interface. That's a spec'd out DMTF standard way of talking to the Redfish service. And we've added the REST-EX protocol in the UEFI spec. So they're starting to build up some standard way of communicating with the Redfish service. So yeah, the natural next extension is that we start seeing shell commands and maybe native apps that work with it in UEFI. Yeah. All right, thank you.